Good morning, students. Myself, Vijay Shankar from EC Department, Chippewa Engineering College. The last two classes, we discussed about the examples, the Fourier transformation. And today class also, you go for the some examples in the Fourier transformation and the inverse Fourier transformation also. Okay. So the Fourier transformation of sinusoidal signal. Fourier transformation of a sinusoidal signal. Sinusoidal signal sine omega t. For our convenience, I'm not taking the a into sine omega t. So directly I'm taking the x of t is equal to sine omega naught t. Sine omega naught t. Okay. And the Fourier transformation definition saying that x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. To find out the Fourier transformation of sinusoidal signal, we are not using the definition of the Fourier transformation, but you have to use the one of the Fourier transformation of the constant. That is a constant, one Fourier transformation of 1. What is a Fourier transformation of 1? One Fourier transformation is 2 pi into delta omega. Last class we derived this one, 2 pi into delta of omega by using the duality property. We prove that it is a Fourier transformation of 1 is 2 pi delta omega. And what is the Fourier transformation of 1 by 2? 1 by 2. The cross multiply here. The Fourier transformation of 1 by 2 is pi into delta omega. Pi into delta omega. Means here the x of t. In this definition, the x of t is 1 by 2. X of t is 1 by 2. Then 1 by 2 the e power minus j omega t dt is the x of omega. So when we take the x of t is a 1 by 2, the Fourier transformation of 1 by 2 is a pi into delta of omega, where the omega is here, you get the x of omega. The change of omega, the delta of omega is also changes. Got it, my students? So I will explain this in the whiteboard. Let's take the x of t is a sine omega t. Fourier transformation of sine omega naught t. So find the Fourier transformation. Okay. The sine omega naught t is equal to, we can write this as in terms of the exponential values, e power plus j omega naught t minus e power minus j omega naught t by 2j. The sinusoidal function can expressed in the exponential values. Okay. In the definition of x of omega, the integral minus infinite to infinite. What is the x of t at the sine omega naught t? That sine omega naught t is two functions of the exponential. One is e power plus j omega naught t minus e power minus j omega naught t dt. Okay. And write this x of j omega is equal to, not the x of j omega, x of omega is equal to 1 by j. I'm writing here the 1 by j. This is a common. The first integral minus infinite to infinite. Here the 1 by 2 is there, write the 1 by 2. E power plus j omega naught t and e power minus j omega naught t. Rewrite this function as e power minus j into omega is already there here, omega minus into minus, it becomes a plus omega naught into t dt. Got it, my dear students? And the minus the second integral minus 1 by 2 minus integral 1 minus infinite to infinite, and here also the 1 by 2 is there, 1 by 2 e power, both the exponentials are the negative exponentials, so take the minus j is a common, omega plus omega naught into t dt. Okay. Now by using the Fourier transformation of 1 and the 1 by 2, we know one Fourier transformation is 1 Fourier transformation 2 pi into delta omega, 2 pi into delta omega, and 1 by 2 the Fourier transformation is 1 by 2 the Fourier transformation pi into delta omega. Okay. Now observe here also, this is a definition of the Fourier transformation only. Instead of x of t, here the 1 by 2. So we need to find the Fourier transformation of 1 by 2 as omega is omega minus omega naught. Omega is omega minus omega naught. So the x of omega is equal to, we got 1 by j into for the first integral, the Fourier transformation of 1 by 2, that is a pi into delta of omega. But here the omega is omega minus omega naught. And minus the second term also the Fourier transformation of 1 by 2 only. But instead of omega, that is the omega plus omega naught. So pi into delta of omega plus omega naught. What it matters. Therefore, finally I'm writing here, therefore sine omega naught t, its Fourier transformation is I'm taking the common of pi also, pi by j into delta of omega minus omega naught minus pi into delta of omega plus omega. The Fourier transformation of the sine function. Okay. And what is a graphical representation of the frequency? Is a delta of omega minus omega naught. Delta is actually, it is a 0 at the 1, omega minus omega naught, at omega naught it is shifted. This is delta of omega minus omega naught, the delay function. And here the minus of, there is no any pi here, sorry. Pi already taken as a common. And the second term is minus, so it is omega plus omega. Omega plus omega naught means it is a delayed advanced function at minus omega naught. Is a variable of omega, and this is a delta of omega plus omega. Okay, this is a characteristics of the sine omega naught, the Fourier transformation. And here it is a pi by j is also there. That's a magnitude is pi by j. Here the pi by j, and here it is a minus pi by j. Minus pi by j. Got it, madam? Observe here. This x of t, the sine omega naught t, we got remove this a. There is no any a here. I'm not taking this a. Pi by j, delta of omega minus omega naught minus delta omega plus omega. For the sinusoidal function as an x of t, the time domain function, the frequency domain function is in terms of delta, pi into delta of omega minus omega naught and minus pi into delta omega plus omega. Similarly, for cosine function also, cos omega naught t. What is the difference of cos omega naught t here? The same thing, e power j omega naught t plus e power minus j omega naught t by 2. There is no any j. The cos omega naught t, the exponential value is e power j omega naught t plus e power minus j omega naught t by 2. So directly I'm writing here the cos omega naught t, the Fourier transformation is cos omega naught t. Its Fourier transformation is pi into, that is there is no any pi by 2 also, pi into delta omega minus omega naught plus delta omega plus omega. So previously we got this thing, but here the plus is there for the cos, and pi by j. Pi by j means the sine omega naught is a 2 by j. We wrote the Fourier transformation of 1 by 2 is the delta of omega minus omega naught, and pi by 1 by 2 the delta omega plus omega. Both are, it is a positive. For cosine function, the frequency domain is the delayed version is a positive value, the a into delta omega minus omega naught, and delayed function is also the positive sine pi into delta omega plus omega. Okay. So now you can see the inverse Fourier transformation examples. We completed the Fourier transformation example. Now we go for the inverse Fourier transformation. The same. So obtain the Fourier transformation of the t power minus a t mu of t. We already did in the last class. That is 1 by a plus j omega whole square. And find the inverse Fourier transformation of the given x of omega is equal to 2 j omega plus 1 by j omega plus 2 whole square by the partial fraction expansion method. And the second example, they are asking find the inverse Fourier transformation of 1 by a plus j omega whole square by using the convolution property. And the third one, x of omega is equal to e power minus j, the magnitude of omega, and x of omega is equal to e power minus 2 omega into theta of omega. So first of all, you can take the first example. The x of omega is equal to the given the 2j omega plus 1 by j omega plus 2 whole square by using the partial fraction expansion method. The given the function is frequency domain function, you have to find out the time domain function. 2j omega plus 1 by j omega plus 2 whole square by using the partial differentiation or partial fraction expansion method. So it is in the form of 1 by a square, that is the s plus a whole square. So I am writing this as a by j omega plus 2 plus b by j omega plus 2 whole square plus 2 whole square. So find out the constants of a, b by equating the function here. So what is the equation? The 2j omega plus 1 is equal to a into j omega plus 2 plus b plus b. Okay. Now compare the functions here, j omega coefficient and the left hand side j omega coefficient. A is equal to 2. A is equal to 2. And compare the constants here. The left hand side, the value is 1. Here the constant is 2 into a plus b. 2 into a plus b. When comparing the constants, what is the a? We got the 2. So 1 is equal to 2 into 2 plus b. So what is the b now? The b is equal to 1 minus 4, that is a minus 3. Okay, so a is equal to 2 and the b is equal to minus 3 we got. Therefore, the given function x of omega is equal to, in the form of 2 by j omega plus 2, and the b is plus minus 3 by j omega plus 2 whole square. Now apply the inverse Fourier transformation on both sides. The inverse Fourier transformation of x of omega, and here also the 2 is a constant. The inverse Fourier transformation of 1 by 2, it is a 2 plus j omega and minus 3, you can write here the minus 3. Inverse Fourier transformation of 1 by 2 plus j omega whole square. Yesterday we did the Fourier transformation of e power minus 80 mu of t. What is the Fourier transformation of e power minus 80 mu of t? 1 by a plus j omega. And similarly, we also find the Fourier transformation of t into e power minus 80 mu of t. T into e power minus 80 mu of t also. That is 1 by a plus j omega whole square. So apply these two. So now it is in the form of 1 by a plus j omega. What is the a here? 2. So what is inverse Fourier transformation is? The frequency domain is given. Now we can find out the time domain function. A is the 2 means e power minus 2 into 2 mu of t. So inverse Fourier transformation of x of omega is x of t is equal to 2 into, here the a is a 2, e power minus 2t mu of t. Okay, and minus 3, and now it is in the form of a plus j omega whole square, is t into e power minus 80 mu of t. So t into e power minus 2t mu of t. What it matters. Okay. So finally, you can write this function as x of t is equal to the common term is e power minus t minus 2t mu of t into 2 minus 3t is the inverse Fourier transformation of the given function. See here, we got x of t is equal to 2 into e power minus 2t. This is a direct function. 2 into e power minus 2t mu of t minus 3t mu of t. Okay. By using the partial fraction expansion method, the given x of omega is equal to 2j omega plus 1 by j omega plus 2 whole square. Its time domain function is e power minus 2t mu of t into 2 minus 3t. Or otherwise, 2 into e power minus 2t mu of t minus 3t e power minus 2t mu of t. What it matters, friends? The function we got inverse Fourier transformation of t by using the partial fraction expansion. And second, it is given the x of omega is equal to 1 by a plus j omega, 1 by a plus j omega whole square. What is the Fourier transformation, inverse Fourier transformation of this function? Its inverse Fourier transformation directly by seeing that we know it is a t into e power minus at mu of t only. But how to find out by using the convolution property? What is the convolution property saying? The time is convolution. The time is convolution. That is a light y of t. Its Fourier transformation is a product x of omega into y of omega. Got it, my students? So use this property and you can find out the 1 by a plus j omega whole square. A plus j omega whole square. Okay. So I will explain this on the board. So you have to find out the inverse Fourier transformation of 1 by a plus j omega whole square. It is x of omega is equal. Okay. Find x of t. Is x of t is equal. Okay. By using the convolution property. So x of omega is equal to, by using the convolution property means let us take the x1 of t with the convolution of x2 of t. Its Fourier transformation is x1 of omega into x2 of omega. Got it, my students? So using this convolution property, I'm taking here also the x1 of omega and the x2 of omega. That is equal to the given function is 1. I am taking the 1 plus 1 by a plus j omega and multiplied with 1 by, another one is 1 by a plus j omega. So from this, the x1 of omega is equal to 1 by a plus j omega. Another x2 of omega also the same thing, 1 by a plus j omega. So now here I am applying the inverse Fourier transformation. Inverse Fourier transformation is x1 of t is equal to 1 by a plus j omega means e power minus at mu of t. Okay. E power minus at mu of t. And x2 of t is also e power minus at mu of t. Is a very important, my dear students, listen carefully. E power minus at mu of t, and here also the e power minus at mu of t. But I need the x of t. Given the x of omega, you have to find out the x of t. But what is the x of t here? X of t is equal to The time domain is the convolution between these two signals. X1 of t with the convolution of X2 of t. Got it? So what is the formula for the convolution? Integral minus infinite to infinite. X1 of tau, X2 of t minus tau, d tau. Is a formula for the convolution, the continuous. But what is the X1 of t? The t is replaced with the tau. Integral minus infinite to infinite. Now I am taking this X1 of t. We got X1 of t here. And another X2 of t is also the same thing. First of all, I am taking the X1 of t is e power minus a into t as a tau. Replace the t as a tau, mu of tau also. It is also mu of. Okay, it's a X1 of. And X2 of t. Here the t is replaced with the t minus tau. So e power minus a into t minus tau into mu of t minus tau. Okay. The second function I take that is a X2 of t, e power minus a, they replace the t as a t minus tau and mu of t minus tau. Got it? So in the step function, let me know the mu of tau is equal to 1 for tau is greater than or equal to 0. Because it is a integral with respect to the tau we are applying. Another function is there here, mu of t minus tau is also 1, but for the t minus tau is greater than or equal to 0. Since here the tau is there, the tau is greater than or equal to. Here the t minus tau, it is a shifted version of the tau samples, t minus tau. So from this, the t is greater than or equal to tau, and tau is less than or equal to t. Okay, we got the two ranges. One is tau is greater than or equal to 0, and the same term, the tau is less than or equal to t. So the t is a range in between of 0 to tau, not the 0 to tau, 0 to t. The tau is in the range of 0 to t only, the combined range of the tau. The tau is greater than or equal to 0 and the tau is less than or equal to t. So it is in between of the 0 to t only. So change the limitations here. Change the limitations 0 to t, e power minus at, e power minus a tau, not the t, a tau. And here e power minus at, and minus into minus is a plus, e power plus a tau, plus a tau into d tau is there, into d tau. Got it, my students? Now, e power minus at is a constant because the integral is with respect to the tau only, e power minus at, and the e power minus a tau and e power plus a tau. Both the bases are the same. You can add the powers. And adding the powers, the minus and the plus becomes a 0. So integral 0 to t, the value is e power 0, 1 into d tau. 1 into d tau. Okay, the integral of 1. What is the integral of 1 with respect to the tau? It's a tau only. Okay, so e power minus at, the tau with upper limit is t, lower limit is 0. Now substituting the upper limit, the value becomes of t, lower limit is 0. So t into e power minus at. T into e power minus at. Okay. So we take the from 0 to t, it means it is up to the infinite only. Therefore, finally, given the 1 by a plus j omega whole square, we know that is directly saying that t into e power minus at mu of t only. So 1 by a plus j omega whole square. Its inverse Fourier transformation is t into e power minus at, t into e power minus at. Because it is from 0 to the values, we can multiply, that is a mu of t also. Okay. The inverse Fourier transformation of the given function by using the convolution property. First of all, the given function, you can split the two parts as a product. Let it be the assume x1 of omega and x2 of omega, and apply the inverse Fourier transformation here itself, the two functions. But we need the x of t, not the x1 and the x2. We need the x of t because the given is x of omega. So apply the convolution formula here, substitute these two values and simplify. Finally, you get the 1 by a plus j omega whole square is a t into e power minus at mu of t. Okay, it is a very important minus. Okay. The first one we got by using the partial expansion method. Second one also we got by using the convolution property. And you see the third one. Third one here, e power minus j magnitude of omega. E power minus magnitude of omega. You know the e power minus a magnitude of t. Same thing here, the x of omega given, x of omega is equal to, something is a e power minus j, not that there is no any j here, only the magnitude of omega. And the fourth one is that the x of omega is equal to e power minus 2 omega into mu of omega. So both are, it is directly by using the inverse Fourier transformation only. E power minus 2 omega here. E power minus 2 omega into mu of omega. The exponentially in terms of, let us directly you can apply that its inverse Fourier transformation definition. X of t is equal to 1 by 2 pi integral minus infinite to infinite. The given function x of omega into e power plus j omega t, and it is a d omega. Okay, and 1 by 2 pi, the integral minus infinite to infinite. What is the x of omega given? E power minus omega, e power minus the magnitude of omega, and e power plus j omega t d omega. Got it, my students? Now, whenever it is a omega is a minus value, it becomes a plus, and whenever the omega is a plus value, it is a minus value. So that is equal to 1 by 2 pi is a common term. For minus values means from minus infinite to the 0. For minus infinite to the 0, it is a minus, so e power omega only. E power omega into e power j omega t. E power j omega t into d omega plus, and for the positive values 0 to infinite, e power omega here, e power omega, and e power j omega t d omega. Okay, my dear friends. So both the bases are the same here. Both the bases are same. So the given x of t is equal to, now the x of t is equal to, we got 1 by 2 pi, 1 by 2 pi. The first integral is a minus infinite to 0, the e power. We are applying the integral with respect to the omega. So take the omega as a common. Omega is a common, 1 plus j into t, d omega. And the second one here, the integral 0 to infinite, the e power, here it is a minus, students. So it's a minus into minus, here the minus, e power. Again, the omega you can take as a common, jt minus 1 here, or minus 1 plus j into t, d omega. So now apply the integration with respect to the omega, 1 by 2 pi, 1 by 2 pi, the e power omega into 1 plus j into t whole divided by 1 plus j into t, with upper limit is 0 and lower limit is a minus infinite. And for the second one, e power omega jt minus 1 by jt minus 1, with upper limit is infinite and lower limit is 0. Okay. So 1 by 2 pi into, for the first one, e power 0 is a value is 1. So 1 by 1 plus jt, plus, for here, the lower limit is there. The lower limit is a 0. So minus will get minus 1 by jt minus 1. So rewrite this function again, the 1 by 2 pi into, you take the minus as a common here, 1 minus j into t. So a plus b into a minus b is a square minus b square. So it is a 1 square plus t square. Here it is a 1 minus jt, 1 minus j into t, plus, so this already minus is multiplied here, 1 plus jt. So jt minus jt get cancelled. 2 is there, the 2 is also get cancelled here. So finally we got 1 by pi into 1 plus t square. This is a e power magnitude of omega. If it is a e power minus j omega, e power minus j omega means directly you can substitute that in the e power minus j omega here. E power minus j omega. If suppose it is a e power minus j omega, as a given Fourier inverse Fourier transformation, you have to find out, into e power plus j omega into t. So e power, take the omega as a common term, jt minus 1 minus j, or you can take the common of j also, t minus 1. Like that you can proceed. Got it, my students? That is the third one. And similarly, the x of omega is equal to e power minus 3 omega, 2 omega, I think. 2 omega into mu of omega. So given function is x of omega is equal to, fourth one, e power minus 2 omega into mu of omega. So what is the inverse Fourier transformation definition? X of t is equal to 1 by 2 pi integral minus infinite to infinite. The x of omega is directly I'm substituting here, e power minus 2 omega into mu of omega, e power plus j omega into t d omega. That mu of omega is only the value is 1 from 0 to infinite. So e power minus 2 omega into e power into n plus j omega t d omega. That is equal to 1 by 2 pi. 1 by 2 pi. Both the bases are same. E power. Take the common of omega. Jt minus 2 by Jt minus 2 with upper limit is infinite and lower limit is a 0. So 1 by 2 pi into, when you can substitute the upper limit, we'll get the 0, lower limit is a minus, and e power 0 is a 1. So 1 by 2 minus Jt is an inverse Fourier transformation of the given function.